Now we'll start by modelling the equipment in CADWorks Equipment. So I'm going to create a new item of equipment. This will be our vessel V101 in the CADWorks Equipment panel, and show that the orientation is vertical. And now I'll position using the placement tab at coordinates of x 2.5 meters and y 11.5 meters and z 0. Now I can start building the vessel using the components tab, and I will start by placing a skirt. Here is our skirt. Now CADWorks Equipment is a parametric modeler, so I will use the parameters in the table here to adjust the equipment model. First of all, changing the length 1 meter, and the diameter will be 1.8 meters, and the base ring, I will attach a base ring with gussets. I'm happy with the rest of the parameters. Note here the wall thickness 6.25 millimeters. Let's now place the next component, the bottom head. I can change the name, let's call it bottom head, and we'll add the main shell and the top head. On the main shell, the circular cylinder, let's change the length 3.5 meters, and then onto this shell we will attach the nozzle. I'll call this N1, and N1 is currently around the back, so let's change the layout angle to 180 degrees, and we'll move it up 2.55 meters along the shell. Finally, changing the nozzle to a 6-inch nozzle with a class 300 flange, like so. Vessel's now complete. We can now export this for analysis to PV Elite. I will do that by hitting the export button, and then I'll make a selection, and I'll select in the graphics. Placing this into my integration folder, and we'll call it V101, creating a native pvelite.pvdb file. The log file appears. This tells me the model was exported successfully, so I can now move to PV Elite for the analysis portion. So in PV Elite, all we need to do is a file open process. Here is V101, a native PVDB file, which I can open, and when I switch to metric units, you can see all of the parameters brought through from CADWorks. Here is the top head, here is nozzle N1, 3.5 meters in length. However, you may have noticed I never specified any material information within CADWorks. As such, we have some slightly odd information here in PV Elite. The required thickness, for example, is 1.5 meters. This is because we have in the material properties, because I've not selected anything, we have these odd numbers here of 0.1 megapascals for the allowable stresses. However, this is easily resolved within PV Elite. I simply will reselect an appropriate material from PV Elite's material database, and I'm doing this on the skirt, as you can see, and I will search for 516 grade 70 carbon steel plate. We now have the appropriate 138 megapascals allowable stress. I will next share that information from the skirt to the rest of the vessel using the PV Elite's share function. Whilst I'm in the share dialog box, I will also change the nozzle materials. So my nozzle material will be A106 grade B, carbon steel pipe. There are no pads, but the flange material we'll also select, and this will be A105. Class 300, and we'll update the nozzle. And then click OK to share the material properties. Now we see on the main shell, the only red text we have is the thickness required due to external pressure, which is 7.98 millimeters. Our thickness 6.25 millimeters, as we saw inside CADWorks. However, to resolve this, I'm not going to change the thickness here. I'm going to take a different approach. I'm going to ask PV-Elite to select me a stiffening ring for the external pressure. A AISC bar type stiffening ring will suit here. So when we run the analysis, PV-Elite will select a suitable stiffening ring. This will be a more visual change that we can see when we return back into CADWorks. A couple more small changes we need to make. We've changed the material on the skirt and the main parts of the vessel. We also need to do this for the base ring. As you can see, we have 0 in the elastic modulus field here. So let's reselect a suitable material. Again, I'm going to pick 516 grade 70. Okay. And one final thing, we'll take a look at the nozzle. However, because the shell is not passing, the shell is still failing its calculations, we can't perform the nozzle calculations. So we don't know if the nozzle is acceptable or not until we've performed the analysis, but I am going to specify the nozzle world seam efficiencies here for both the nozzle and shell. And with that, I will now run the analysis. Okay, I have a warning, one of the nozzles failed the code requirements. Okay, that was the one nozzle we couldn't check during the input because of course the shell didn't pass its calculation. So now when we see in the output, we have a couple of warnings, but let's take a look at the nozzle first of all. The nozzle fails the calculation, and if we scroll down we can see the area replacement calculation has failed. PV-Elite recommends that we add a reinforcing pad. So let's close this down and return to the input. And as we return to the input, we see a message that the input for this model was modified by another process. So let's say yes, load those new changes in, and here we see the stiffening ring added by PV-Elite. And now we see when we select the main shell, no red text, our thickness is sufficient due to the stiffening ring. Let's return to the nozzle. Now I can see the results of the nozzle calculation. This fails. So PV-Elite suggests add a reinforcing pad rather to the nozzle, which we do. As soon as we add that, I now see the area replacement calculation passes. I do see one other piece of red text. The weld calculation has updated and now passes once I change the value. So everything is acceptable here. I will click OK. And I will run the analysis one final time. That was our only issue, of course, on the nozzle. Analysis is complete. We have the green check. And in our output we see no more red reports. We have a small warning here on the base ring calculations, but it's nothing to be concerned about. So we can now take that back into CADWorks. So let's close down the vessel in PV-Elite, return to CADWorks and import that back, choosing a PV-Elite import, vessel V101. We open the file and CADWorks says an equipment with that name, V101, already exists. Do I want to redefine that? Well, yes I do, so I simply say yes. The PV-Elite file gets re-imported, and here we can see the stiffening ring, and here we can see the reinforcing pad that has been placed onto the nozzle, also visible in the properties here with the dimensional data the same as was in PV-Elite. So what I could do now is I could save this vessel back to my equipment library for use in a future project. I know that this is acceptable, it's code compliant. Saving it back to the library will allow me to rebuild and reuse that vessel in any other project, any other drawing, simply by restoring from the library. However, I'm not going to do that here, but what I am going to do is use the library to place the pumps. So here's my equipment library. There's a number of equipment items in this library here. I have one called the Tech Day pump, which I'm going to search for and insert. I'll insert it at the appropriate location, which will be X minus 550, Y 500, Z 600, and this orientation. Now CADWorks will build the equipment, build the pump, in the same way as I built the vessel, except for instead of me having to specify the parameters are obtained from the library. You'll also notice here that the motor is a detail representation, so you can use any DWG block for any of the parts, not necessarily just the primitives that we supply out of the box with CADWorks equipment. This pump motor was generated using BricsCAD Mechanical, for example. Of course, we have two pumps, so I'm just going to use the copy function to create the second pump spaced 1.5 meters from our first one. And there is our completed equipment drawing. So let's save that, and I'll save this in my integration folder called equipment.